Now, we're going to move into a very important idea in calculus, approximating area under a curve. We want to find the area between a curve f of x, the x-axis, and between the 2 points x equals a to x equals b. So visually, you can imagine this curve here and the shaded region underneath it. That's the area we are trying to approximate. Now, here's the main idea. We approximate the area using rectangles. Instead of trying to find the exact curved area right away, we break it into simple shapes, rectangles, that are easier to calculate. Then we add up the areas of those rectangles. Let's use the graph on the right to understand this. Here is our interval from A to B. Now I'm going to split it into 4 equal parts. Now we have 1, 2, 3, 4 smaller regions. Each of these is called a subinterval. So instead of one big region, we now have smaller pieces that are easier to work with. Now, on each of these subintervals, we build a rectangle. Each rectangle sits on the interval and goes up to the curve. So instead of the curved area, we are using rectangles to approximate the area. To find the area of each rectangle, we use the formula length times width. Now let's talk about the width. Each rectangle has the same width. We call this delta x. To find the width of each rectangle, we take b minus a divided by n. In our example, n is 4. So delta x is just the width of each small interval. And the formula for delta x is b minus a over n. Now, let's label each point. We call this x0, x1, x2, x3, x4. Each of these points marks the boundary of a subinterval. And we can find each one using this formula, xi equals a plus I times delta x. This just means we start at A, then we move to the right in steps of size delta x. I tells us how many steps we take. The total area is approximately the sum of the areas of these rectangles. And here's an important idea. The more rectangles we use, the better our approximation becomes. Now let's define an important term. A partition is just a set of points, x0, x1, x2, x3, all the way to xn, where x0 is less than x1, is less than x2, is less than x3, and so on. And x0 is a, and xn is b. So basically, we are splitting the interval from a to b into smaller pieces. Each small piece is called a subinterval. If all the pieces are the same size, we call it a regular partition. And in this section, we will mostly work with equal width intervals, so regular partitions. Next, we'll look at specific ways to build rectangles, starting with the left endpoint approximations.